when you're doing partial fractions, we know how to take two separate fractions like this. These are your partial fractions. We know how to take those fractions and add them together. How do we add them together? We make common denominators. In this case, what would be the common denominator?
You gotta multiply them.
You would have to multiply the denominators, okay? And so we would do that, which means we would take the first fraction times what? So times the x minus 4, and I would get 2x minus 8. And then I would take the second fraction times
6x plus 18.
yeah, exactly, because I would take it times x plus 3, and I would get 6x plus 18. Then what do I do with those two fractions? I add them together. Okay, do I change the denominator? Nope. I get, if I add, yes, I'd add my numerators and I would get 8x plus 10. Okay, so I know how to add fractions.
So we're going to work backwards and make it.
Okay, so that's the answer. What you're supposed to do now, I'm going to give you the answer, and you've got to, exactly, you have to decompose it and figure out what were the fractions that made it. It's not that bad. It's actually pretty amazing. Okay. All right. So, what you're going to do then, if I've given you this starting fraction, because you're going to factor your denominator, I've already got factors here, so therefore you know your common denominators had to come from a fraction that had x plus 3 and one that had x minus 4. Caleb, every time is annoying. So, if I have x plus 3 and x minus 4. Now, here's the wrinkle. How do you figure out what might have been on top?
Luke, put your hand up.
Okay.
You gotta put that back in there, right?
Okay. Now, this method only works if the numerator had a smaller power. Guys, you need to hear this. This is the critical, how you set them up. The numerator, up here, notice the original, we had a 2 on top and a 6 on top. The numerator has to be at least 1 power less than the denominator. So if this is a first power, that means up on top, there could have been no power. It had to be just a constant number. So therefore, you aren't going to know what that number is, so you're going to call it A and B.
So if you have like x squared plus 4, then it would be x on top?
Okay, so Nicole just asked me a really good question. If my denominator had x squared plus 3, when you go to do the numerator, 1 less than x squared is the first. You would have an ax, but then you have to go down every power until you get to a constant number. So it could be x plus b. Every time you have to use a different letter. Okay. So if I gave you an x cubed, plus c, you'd have to start 1 less and go all the way down. Okay. So, in our case though, this is a nice one. You only have a single letter on top. You now have to do the algebra to solve for A and B.
That wasn't the answer to the problem.
No, that's just other examples. No. Okay, what you are going to do is you are going to get rid of your fractions first thing. How do you get rid of fractions? You multiply by the common denominator. Okay, you will always, without fail, do not, this is one time I'm telling you not to put your brain in this, do not think. You multiply by the original denominator. Do not use your own brain about thinking about this, and I'll show you why on another problem. But multiply by the original denominator, and you will be correct. So, consequently, the x plus 3 and the x minus 4 cancel, do they not? So what's left here? 8x plus 10. Okay. Now, Luke Kulik. So when I take x plus 3 and x minus 4, the x plus 3 cancels. What's left? Okay, I'm not going to distribute it because I don't want to lose anybody, and I think you make mistakes if you do too much in your head. So I'm just writing down what's left. And then, if I take this one times x plus 3 and x minus 4, the x minus 4's leave, and I'm left with b and x plus 3. Now, go back and distribute. So this is going to be a x minus 4a and bx, gentlemen, plus 3b. That a went bad. Okay, now here's the amazing part. How on earth do I solve for a and b when I've got this mess? No, this is the cool part.
You go talk to a mathematician and you let him do it for you.
This is algebra 1 for the rest. Don't solve the rest of it. Okay, since this is an 8x, okay, the coefficient is 8. Shouldn't all the coefficients on the x terms over here have to add up to the 8? So therefore, you drop the variables and you say 8 must equal a plus b. And then you go do the same thing with the numbers. 10 for a plus 3b. Okay. Then, now, do we know how to solve this for a and b?
No.
Algebra 1, Algebra 2. They'll learn Algebra 2's assignments on this right now, this very moment. Can I say elimination, substitution? Elimination's the fast way. Could solve it by Cramer's rule, matrix equations, all those different methods. Okay, elimination usually works fine. So, you have to go, am I going to eliminate A's or B's? I would do A's because you want them to, one to be positive and one to be negative. They have opposite signs. So I would do the A's, which means I need to multiply by 4. So I'm going to get 32 equals 4a plus 4b. And the other one's fine, so I'm going to copy it down. And then, yes, you always add down. So the 4a's cancel, and I would have, yes. Because I wanted to make the a's cancel. So b is 6. And you can sub that, I would sub that in this first one, you can sub it in anywhere. Yeah. If b is 6, then 8 equals a plus 6. A2. Now, your final answer, though, is not 2 and 6. Your final answer is what would the actual fractions have been that created this.
That would have been.
So you have to go back up here to the original and go, oh, a was 2, so I would have had 2 over x plus 3.
How did you just get A? Oh, never mind.
I subbed it in here. Just sub it into one of your equations, doesn't matter which one.
I get it. Yay. That's our answer. You can do it.
6 over x minus 4. Okay, the concept of what to do isn't hard. It's so easy to make an algebra mistake in all of this. That's silly.
So basically on our homework, if it doesn't come out,
Don't erase it. That's why I said I'll spend the first half an hour of class next time running around finding it. Okay, I want to at least start another one. We won't maybe get it done, but I want to start it. Okay. Sorry, I started recording. So if those were the denominators, that would just have a and b on top. What if I had given you factors of x squared plus 4 and x cubed plus 7? Okay. So the x squared plus 4, what? Oh, sorry. Okay, so if this is x squared, what are you putting on top? Ax plus b, and then if the second fraction is x cubed plus 7, you got to keep going different letters, so it can't be an a. It'd be a cx squared. You'd have to go all the way down to a constant number, so plus e. You've got to use a different letter every single time.
Cody. A different letter every single time.
Okay, here's the one that's going to drive you crazy.
So this one's right down here.
Yeah. This is the special case. It drives people nuts. If you have a lone x cubed, a lone variable, okay, if x cubed was one of your denominators, okay, if it was a lone variable, you can only have a single letter on top. There would not have been an x plus 2 on the top of an x cubed. So that would just be an a. But the problem is, x cubed, couldn't it have been made up of x squared times x to get x cubed? So therefore, you have to compensate for the fact that there could have been an x squared or there could have been an x.
What? Lord have mercy.
Okay, but if it's a single letter, single variable, single letter on top. Okay, now, chances are good, one or more of those letters on top will turn out to be 0. Chances are good all three did not exist in this problem, but you don't know. So it's very possible as you solve it, one of them will come out to be 0. Not in, you have one where there's a single variable, yes.
I got the question though.
Okay, and then if this was 4x plus 1, what would be on top? D. Yeah. All right. Yes, shoot. No. I need to teach. Now check your journal. You got plenty of time to ask me about a journal. Okay. So now, what if I have a quantity squared? Yes, it's the same thing. You have to go, oh, there could have been an x minus 5 squared, but there could have also been an x minus 5 to the first power, and then, of course, there could have been the x plus 3. Now, the one I'm interested in is what goes on the top of this first one, an a or an ax squared? You look at what's in the quantity inside. Don't look at the 2 power on the outside. If that's an x to the first on the inside, it's just an a on top. Look at what's inside. And b and c.
So on our journal, they're all just pluses. We can't have like a and then ax plus b.
Okay. Always set up every single thing with plus signs in it. If there was a subtraction, like here, b will turn out to be negative. When you solve it, you'll get a negative number for b if it was actually subtraction. So set up everything on top with plus signs. If there was a subtraction, it'll turn out in the number as a negative number. But it'll make your, if you put subtraction signs in them, it just makes there more chance for errors. Because that's more negatives, we can mess up.
Come on, Miss Meyer, you're wasting time.
All right.
Yeah.
Well, at least talk about how to start this. I will actually post this problem completely done. So there's another set of notes.
Are we gonna have to do like bottom number?
Yes, I do mean 3x squared. Thank you. Yeah. Okay. No. No, it won't be that hideous. You could. It could make you do synthetic division to get the bottom factor. That would be really mean. It's possible, but I wouldn't do that to you. No. Okay, so if I give you something something hideous like this with 4 terms is not going to make you synthetic division it, so what's your only choice?
Group it.
It's factoring by grouping. Yeah. So I would ask you to factor that one by grouping. Pull out your x squared out of the first 2. What can you pull out of the second 2? A positive 4. And so what will my factors be? You're not done here. People always think they're done. Pull out x plus 3, and so therefore you would have x squared plus 4. So when you go to set up your problem then, what's on the bottom of your fractions? X plus 3 and x squared plus 4. Okay, what goes on top? A on the first one. Go 1 power less. With 2, that's 2, so you would go 1, and then keep going down until you get to a constant number. C. Yep, you completely ignore what's on top. That has nothing to do with it.
But then you get that back, right?
Yes.